So now we're going to look at our problem again. So let's grab our tangent line again. Let's grab our circle. Let's grab the other circle. And then the circle of mutually tangent circle. So anyway, tangent to everything. So what we're going to get is that, the radius of this is R1. And so you can draw a vertical. Because of the fact that it's tangent, it's going to be perpendicular. And so we get R1 there. We're going to draw that. That's R1. We're going to grab another one. On the other circle, goes all the way up to the center. That's going to have length R2. And the circle here is going to have, radius R3. And now we're just going to make a bunch of triangles and figure out what R3 is. That's essentially the strategy. And it actually works pretty well because you get the solution. So these two are tangent at this point, which means that if you get a line that connects between the two of them, its length is just going to be the sum of the radii. So it's R1 plus R2. No problem. No problem. Then I have R1 plus R2. And if you get the line across, you're going to just get the line across right here. No problem. It's going to make a right triangle. It's making a right because that's perpendicular. So the distance here, right here, this is height R1. So this is R1 minus R2. Or sorry, R2 minus R1. And from this, what we're going to get is that this length over here, the distance between this point here and this point here, is going to be 2 times the square root of R1, R2. 2 square root R1, R2. No problem. So now what we're going to look at is this triangle. So we're going to look at a triangle where it goes from here, goes tangent to there, and then, straight line across. So because it's tangent by the same principle, we can just draw our triangle out. So this one is just going to be R1 plus R3. That one's just R1 plus R3. Since this height over here is going to be R3, it's not too hard to see. This thing is going to be R1 minus R3. The height there is R1 minus R3. And what's the distance across? That one, we're by similar, it's just going to be by using the Pythagorean theorem, you figure out it's 2 times the square root of R1, R3. Now consider this. Draw a line going from the center of the smaller circle all the way across, and then have this thing connect to the center of the bigger circle. So by similar reasoning, because it's similar reasoning, it's going to be 2 times the length of this thing is going to be 2 times the square root of R2 times R3. So what we're going to get is this following equation. It's going to be the fact that 2 times the square root of R1, R3 plus 2 times the square root of R2, R3 is equal to 2 times the square root of R1, R2. Okay. So now what we're going to do is, we take off the 2's. We don't need them. Divide both sides by 2. We use the distributive property, so we get square root of R3 times the square root of R1 plus R2 is going to be equal to the square root of R1, R2. No problem. And what we're going to do now is divide both sides by this term here. When you get the square root of R3 is equal to the square root of R1, R2 over square root of R1 plus the square root of R2. And so actually what this is interesting is that if you divide, the numerator and denominator by square root of R1, R2, you get that the square root of R3 is equal to the harmonic mean of the square roots of both these numbers. So it's 1 over square root R1, or well, actually, I mean, technically, if you want to be pedantic, this is R2, plus 1 over the square root of R1. And so, this is interesting. And, you could square R3, but I don't want to because it's just not going to be as nice looking. It's just not, it's not as elegant. So anyway, what we're going to do is show a very simple example of how this works. So we're just going to take the simple example or instance where R1 equals R2. And so let's just simplify it, just call it R. So then let's use this equation because I think this is better than that. And so we get square root of R3 equals, these two are equal, so it's R over 2 times the square root of R. And so then R3 is just equal to R over 4, which I don't think is too hard to justify, but, that's that. So it's R over 4, and let's draw this out and just show you what we're talking about. So look at it like this. And so one circle over here, whoops, shoot. Something went wrong. Okay, just take this. Let's assume it's the same circle, even though it's not. And then make your tiny little circle. So this isn't exactly visually pleasing, but, it is what it is. So the distance between here is just going to be equal to R across. So that's R. Go from here. You have no violation. And so nothing is being violated here. So if you look at this particular triangle, where you're going to find is that, this one's just going to be 5 over 4R. The hypotenuse is. The distance across is R, and this one here is 3 over 4R. So you have a 3, 4, 5 triangle. So it's completely fine. So it actually did work out pretty well. So in that case, it does work. And this is all I had to say. Hopefully you guys like this. You can go try it out. But anyway, I think the reasoning on this is completely accurate. Anyway, thank you guys for watching. Thank you. I appreciate it.